All right, and so joined by phone, Jillian?
Yeah, that's Jillian.
Good morning, Jillian. Good timing. How are you?
I'm good. How are you, Janet?
Excellent. So we have a full room here today. We have people from your school. Rebecca is joined with several classrooms, and there's Mindy Bell and Susan Steiner and Jan Gray, and who else do we have here? We have a John Worssam, I'm assuming a relation to you. Jennifer, Anita, Kathy Burnett, sorry if I mispronounce your name, Misty Nicola, and Susan Steiner have all joined us from all over the United States this morning.
Excellent.
Hi, Jennifer Hammond's on the call too.
Oh, good. Somebody just joined by phone. Hi, Jennifer. Jillian, I don't know how good our connection's going to be, but I've just started the recording, so I'm just going to go through our intro slides, and then I'll turn it over to you, okay?
Oh, marvelous.
Did that sound like a good plan?
Yeah, that sounds great.
Okay. So I want to welcome everybody to our PolarConnect event. It's with Jillian Worssam and the team. They're aboard the Nathaniel B. Palmer somewhere in the Southern Ocean. We'll hear a little bit more about where they are and what they're doing in a moment. It's October 15th, 2014. A few things about using this platform and joining a PolarConnect event that I need to relay to you. If you're joined virtually today, the slide should have changed for you, and you should see a slide that shows the Blackboard Collaborate platform and how to use it. You'll see that there's a list of participants on the far right, left, and below that there should be a little box that's a chat area. You can type your questions or your hellos or your comments in that chat box, and it will go to everyone in the main room. For today's event, realize that Jillian is not going to be able to see what is in that chat box, but you can still type things away, and I will relay them to her via the phone. I'm connected by phone as well. If you're in a room with lots of background noise and you are calling in by phone, you need to mute your phones, *6 to mute it and *6 to unmute it. And if you want to ask questions later on live, we'll go through it again, but you click on the talk button, which is above the list of participants. That opens up your mic, and you ask your question or make your comment, and then click on the talk button again to close it. And that should take care of any background noise we'll have. And then today's event will be archived so that you can share it with others later on, or if you have to leave early for some reason, catch up with the rest of it. So the next slide is participant introductions. We will not go through all the room. I'll let you, if you're her students or something, Jillian's students or friends, you can say hi at the very end or during your questions. But for all of us and for record keeping sakes, we'd like you to introduce yourself through the chat box. Tell us who you are, where you are, and if you have students or adults that are joining it, put that all in the chat box. While you're doing that, I'm going to explain a little bit about why Jillian is off in the Southern Ocean. She's part of the PolarTREC Teachers and Researchers Exploring and Collaborating program. We're funded by the National Science Foundation, and we're a professional development experience. This just means it's the experience for teachers so they can work side by side with scientists in the Antarctic and the Arctic. We've been doing this for over 10 years, sending teachers from the United States with scientists to the polar regions so that they can learn more about science, in particular the issues and things that are happening in the polar regions, and bring them back to you wherever you are in classrooms around the United States. So Jillian applied to the program and is part of that, and she's been matched with a research team that is looking at the ocean and ocean currents, and we're going to hear a lot about that in a moment. Very quickly, if you have a question during the yes, Jillian?
Can we move through this? We're losing our signal.
Okay. Yes. Well,
sorry.
That's okay. I expect we're going to lose the signal a lot, so when you disconnect, I'll hear it and I'll relay it to everybody, and then we'll just pick up again, just redial and come back. So we're on your title slide, so go ahead and say hello to everybody.
Hey everybody, and welcome from the Southern Ocean by South Georgia Island. I think you can see our route there.
And we just lost.
Chile.
Oh, there we are. Go ahead. Sorry, Jillian.
Still here?
Yes, you cut out for just a moment. You said something about your route, so kind of start again with the route part.
Well, we left Punta Arenas, Chile over 20 days ago and are now in the Southern Ocean south of South Georgia. We've been studying seafloor spreading in the Antarctic Circumpolar Current, and I'm here today with Ian Dale, our chief principal investigator scientist of the expedition, and Stefan Saustrup, who is one of our lead scientists who's going to explain a lot more too. Let's go to the next slide, and Ian can introduce our expedition.
Yeah, hello everybody. Welcome to the Nathaniel Palmer down here in the Scotia Sea, south of the island of South Georgia. We're here to try to understand the Antarctic Circumpolar Current, which is the planet's greatest current in terms of the volume of water that passes any point at any time, flows right around the Antarctic continent. And it is controlled by tectonics, by the motion of small crustal blocks and major continents around Antarctica, and that is what we are trying to understand through using a number of different science techniques, through studying the morphology of the ocean floor, marine magnetics, the way that plates have moved through time, and also the island of South Georgia, which you see in the top right of your map there on the next slide. You'll see the island of South Georgia at sort of 1 o'clock on that slide in the northeast of the Scotia Sea. So we are down to the immediate southwest of South Georgia, towards the center of the Scotia Sea, compared with that island. And we've been working around the island doing seismic work, which Stefan will talk about, as well as magnetics and gravity and all the things that help us to understand the ocean floor and the motion of the different plates around this very complicated Scotia Sea area. We've also been putting GPS, global positioning system, receivers on the island itself, because we think that its motion is changing. It has moved away from South America for a long way, and we now think it is beginning to move back with South America again, and that is a part of the opening of gateways for the Antarctic Circumpolar Current to flow around the Antarctic continent. So that's a broad overview of what we're doing, and with that I'll pass it back to Jillian.
Do you still have us, Janet?
Yes, we do. We can hear you great.
Excellent. Just to show you the scientific team, there's 17 members, and it is a collection of geophysicists, geologists, ecologists, marine biologists, engineers. It's a phenomenal collection of it's a phenomenal brain collection, including 6 students from the University of Texas. So it's been wonderful to work with the professionals as well as the students as they learn more, as they move forward in their career. Now we'll move into the science portion, and Stefan's going to start us off in teaching us a little bit about the tools that are used to map the ocean floor.
Hello everybody, this is Stefan Saustrup. I work with Ian at the Jackson School at the University of Texas. I'm now on the slide that talks about the multi-beam. One of the tools we use is a multi-beam bathymetric imaging tool that, just like the word multi-beam, it has 400 beams that are arranged in a fan shape that give us very high resolution image of the seafloor as we move along. And as we move, we get a swath of very accurate water depths. And then we move over a little bit and come back by, and just like mowing the lawn, we sort of build a map of the ocean floor. And then I'm going to the next slide that talks about the newts and chirp. This also uses acoustic energy to image the seafloor, but it's a little bit lower frequency and can penetrate below the seafloor and get us tens of meters of image of the geology just beneath the seafloor. I'm going to move to the next slide talking about the seismic system. We have an airgun seismic system that uses compressed air to generate sound energy that's towed behind the ship. Oh yeah, that's me in the blue baseball cap and blue jacket, and you'll see the seismic source is towed behind the ship, and this uses big orange buoys to buoy it. There's a slide on the right-hand side of us deploying this gear. We have the marine techs from the boat or out in the back harnessed in and deploying the gear. On the upper left, you see what the seismic sources look like laying on the deck. I'm going to go to the next slide, and this shows the system fully deployed. We tow a streamer, seismic streamer, behind the boat that has our receivers in it. It has hydrophones, which are essentially underwater microphones, and they receive energy that bounces off the seafloor and actually penetrates, and this gets up to 1 kilometer deep through the geology and comes back up, and we record those and are able to turn them into images of the geology that we cannot see. And it works.
Jillian? Hello? All right, we lost, yep, there they beeped out there for a moment. So we will have to wait for them to come back and join us and continue on. This is the way satellites work. If you're lucky, you get about 5-10 minutes of good satellite reception for talking, and then it beeps out and drops the signal. So that's the way it is. If you have questions, please type them. Or if you have things you want me to relay to the team, if they're talking too fast for you, I can tell them to slow down or spend a little more time on the slides or whatever you need. So, and questions that you want me to relay, I'll also write down, and I see that there's already one from classroom already. Okay. Otherwise, for the teachers in the audience out there, is the sound and slides going okay?
We're back.
Excellent. Hey, Jillian, we dropped off when he had actually just done a pretty good explanation of the seismic source and the seismic receiver, and then we got a couple of questions that are related to that. So can I ask that right now?
You bet. We're ready for questions.
Okay. One classroom wants to know if you've sensed or mapped any volcanoes underwater.
Yeah, we have mapped several seamounts, which are basically underwater volcanoes. They don't reach the surface of the ocean, but you can see very large bumps, pointy bumps on the bottom.
Okay. Actually, that was it. That's the geology question. Other people are asking about life at sea questions. So I'm sure Jillian has slides about that. So we'll get to those in a moment.
Excellent.
Okay. Can we move forward? Correct. Yes. We can move to the next slide.
Okay, this is Stephen again. I'm on the next slide talking about the seismic data that we record from the seismic streamer, and it sort of shows a cartoon of what happens. You have the energy goes down from the source, bounces off of something, and comes back to the streamer. In the upper left, you see some of the raw data as we record it, and then at the bottom left, you see some of the preliminary process data showing us an image that you can see the seafloor and then a little bit of the geology beneath that. And we're going to go to the next slide. I'm going to hand this over to Ian to talk about the dredging.
Before you leave, there is one question about the magnometer. It says, does the magnometer sense polarity of rocks?
Polarity. Polarity.
Ian, yes, the magnetometer does indeed sense the polarity of the magnetization. And when we are on a normal ocean floor, which is the product of seafloor spreading, we are able and have been mapping these changes in polarity of the magnetization. This slide shows the process of dredging, because somebody asked about the submarine volcanoes, and Stefan told you how we had actually mapped some on the ocean floor. The question is, what age are those volcanoes? And that is critical to our understanding of the ocean floor. These are not no longer active volcanoes that we were talking about that appear as seamounts, as these bumps on the ocean floor and the multi-beam scanning data. But in order to determine their age, we have to sample them. And you see on the left-hand side of that screen there, a big bag hanging below a metal dredge, a steel dredge, which we drag along the ocean floor, and you see it in the middle there, coming back on board, full of rocks. And on the right-hand side, our collaborator Phil Leet from the British Antarctic Survey, who studied these rocks a lot around here over the years, examining them. And here is Phil on the left and myself in the middle, and then on the next slide, looking at these rocks in the laboratory. Phil with a geological hammer, myself with a hand lens, a kind of loop, looking at those and deciding which ones are worthwhile trying to date. And finally, on the right, we, as a byproduct of dredging these rocks, we brought up very few organisms. And you see on the right, top right, our New Zealand government observer for the government of South Georgia, Graham, who is picking up the few biota, the few organisms which we cling to the rocks, which we brought to the surface. And you see an egg-shaped creature that looks a little like a big sea anemone, which it probably is, and something that looks like a big flat fish, gray fish. I'm not sure exactly as a geologist exactly what this critter is, but Graham will be taking it back to some experts in Southern Ocean biology in order to understand that. And in the very next slide, you'll see one referring to the installation ashore of global positioning system. The bottom left shows a geologic map of South Georgia, part of South Georgia, that we use to determine where we're going to put these installations. And in the center, my colleague Bob Smalley and I and Captain Souza of the Nathaniel Palmer are discussing exactly how we're going to get ashore in some very rugged places, which we do in zodiacs, like the inflatable boats like the one you saw in the bottom right there. And many people take part in trying to install these things. If you go to the next slide, you'll see the dome of a receiver, of the antenna for a receiver set up on the island of South Georgia. A broader picture of where that dome is shown on the right, with some of the coastline in the background. And in the center, you see the station set up with solar panels and wind generators, so that it can continue to operate autonomously on its own for, we hope, at least 3 years. As Stefan was involved with a number of other colleagues in setting these up on shore. I'll pass this back to Jillian at this point, but you see in the next slide the group who have just come back from setting up one of these stations, and you see we have to be pretty well muffled up against the weather as we travel ashore in the inflatable boat.
For me personally, this slide is really important because there were quite a few attempts to go ashore, and besides the weather as a challenge, many locations had steep cliffs, rough shorelines, and when you have high swell, it's very difficult and dangerous to get the Zodiac into land. And safety of the people always comes first. Are we still there, Janet?
Yes, we're here listening.
Excellent. So we'll go to the next slide. And we also have on board the vessel as requested by actually NSF and the government of South Georgia. We have 2 protected species observers, as well as Graham from New Zealand. And it's just a little sampling of some of the species that we have seen on our trip. We were very fortunate. In the upper right-hand corner of the picture of me, that's an albatross wing that I'm holding. It's a juvenile wanderer, and so you can see it's quite large. And the picture down in the lower right is me with a juvenile wandering albatross, and they become very, very large. They're amazing species. And I know I got a lot of questions at nighttime when
oops, we just lost Jillian again and the team. So this is a good time to gather your thoughts and get some questions ready. They got a couple more slides about probably like life on the ship and everything. So if you have questions related to that, type them in the chat box at the moment, or we can also go live to some of you and just let me know if you want to ask your questions live. Just type it in the chat box, and I can call on you when she comes back. It's an amazing array of species that she's been able to see. Pretty exciting. So hopefully here we'll have the team join up again. And if any of you are having technical difficulties or can't hear anything, let me know. I know there were questions about what they eat. And where does the food come from? We'll get to that life in the ship stuff here in a moment. Hello, Jillian, you back?
yes, we're back.
All right.
Excellent. We're on the right side.
Yeah, you are. Yes, you're. And I was just telling everybody to kind of get ready with some questions and everything. So we'll get to those in a moment.
Perfect. And the only other thing I wanted to point out that I have also learned, there's so much that I learned on this trip, but one of the things that the protected species observers taught me is that if you look in the upper right-hand corner at the small picture, they're actually able to identify different types of whales based on the shape and height of their blows, which I find quite fascinating. The very next slide is talking about life at sea. There's an amazing crew on board the pond.
Are you there, Jillian?
What?
Oh, we had a little blip. So you were talking about the amazing crew, and then you kind of dropped out for a moment.
It's just that everybody works. It's a vessel that doesn't sleep 24/7. So while some people are working, some people are sleeping, and it's a community at sea. And then the next picture is times if anybody would like to ask questions.
Okay, so we do have a couple of questions that came up. One was earlier about food, and let me see if I can find it again. Kathy's group wants to know, we are wondering what kind of food you have to eat and where does it come from? Are you there? Jillian? Hello? Uh-oh. Hello, Jillian? No. All right, we lost them again. So keep thinking of those questions. We'll get back to the food one again here. And I see about the rock and the animals changing. And again, if anybody wants to ask their question live, let me know and I'll let you go first when she comes back on. What to eat and where does it come from? Okay. I'm just making a note of these questions so that how do with the question about how do the animals change from season to season, are you talking like that, how the species change, or are they? like migration and that kind of question? So whoever, I think it was Kathy that had that question. Okay. So it's a combination. Okay. Season. Well, hopefully they come back so we can answer all these questions. Great questions. What is a typical? Hello, you back?
Hey, Janet, I think you just asked a question about the food on board.
Correct.
The food is excellent. There is a 3-person galley team with a chef. It's amazing food. We've had fresh vegetables for over 2 weeks. Today for lunch we had steak and potatoes, and it's phenomenal food. Absolutely excellent. And today one of the students, it's his 22nd birthday, and they made this amazing chocolate ice cream cake.
Ooh, that sounds nice. Okay, we have several questions. I'll relay them to you here. Let's see. What is the oldest rock you've found so far?
This is Ian. We have to wait until we get the rocks back to the laboratory. We're expecting that we may have a rock on board as old as 80 million years, 80 million years. But we really have to wait until we bring them back to the U.S. and have them studied in the laboratory before we can come up with a totally definitive number.
Wow. So what makes you think it's 80 million years? What do you?
Simply when we were here before, we dredged rock from the same ancient volcano, and we did have it analyzed. The number that we got, which is consistent with our other observations in the region, was 80 million years. However, the analysis was not completely credible. We had to say that that's a number we really like. We would like this volcano to be 80 million years, but science doesn't work that way. You have to be sure that your number is robust, that you could repeat that number. And so we dredged again on the same volcano. We have some more samples. We'll date them. But that's the reason why we think it is probably about 80 million years.
Okay, and related to that, kind of a follow-up question. The person wants to know, do you use a radioisotope dating back in the lab? And what isotope if you do?
That is correct. In fact, we use the ratio of potassium-40 to potassium-39, 2 isotopes. The ratio of those gives us the age of the rock.
All right, excellent. All right, so we have some other questions about animals. So we're going to go back to the animals. A student wants to know where'd it go? How do the animals change from season to season? Do they migrate? Do they change? Do their coats change? How do the animals change?
Different species change in different ways. One of the things that I recently learned, it was in the blog 2 days ago about the birds, is there actually is a South Georgia pin-tailed duck, and it molts every year, and when it molts, it actually changes from a diurnal species to a nocturnal species and only comes out at nighttime because it cannot fly when it's molting. So depending upon the different species, they all have different life cycles that mesh with the seasons. Many of the first hills now are coming on shore because they're about to have pups. So it varies depending on species to species.
Okay, cool. Related to animals, DJ wants to know if you've seen any killer whales.
No, they had one sighting on the bridge of one killer whale, and it was just the back of the animal as it was about to die, but we have not seen any, no, we have not seen any killer whales.
Okay, and what kind of seafloor animals have you seen? And this is coming from your school.
I'm sorry, I can't hear you, Janet.
What kind of seafloor animals have you seen? This is from your school.
I'm sorry, you're breaking up.
What kind of seafloor animals have you seen? Seafloor animals. Oh, there they go. Bye-bye. All right. Thank you, everybody, for hanging out with us here. This is the way it is with the satellite phone. I knew once you started not being able to hear me that we were going to lose a connection again. That's all right. Keep up your questions, your good ones. We'll get back to seafloor animals. Majority. And if for some reason you have to can't hear your question being answered, be sure to type them in the on the website in the forum or in the comment section of the journals, and Jillian can get to them in the next couple of days. So if for some reason we don't get to your question today because of this disconnecting or communication issues, make sure you type those questions to Jillian and the team. And also, if for some reason you have to leave early today before the end of the webinar, this webinar is being archived. We'll post it on the website with a link, and I'll send also a link out to everybody that's registered. So you can catch the end of it if you have to bug out early today. All right, hopefully they will log back on. And if you haven't done so, you could, I see there was a question, where is everybody on the ship from? We also want to know where you're all from. So if you don't mind, type that in the chat box and let me know where you are all from. People. Ooh, this might be a longer than having a harder time connecting, it seems like. I can kind of answer the question about this. Oh, there we go. Okay, so the question was, what kind of seafloor animals have you seen?
Seafloor animals? We've seen no seafloor animals. We're dredging, we're doing work at over 2,000 meters. And we're looking at the seafloor through acoustics, not through cameras. And the dredge only pulled up those two samples that we showed in the slide. Okay.
So the next, kind of back to life on the ship. Somebody wants to know, what is a typical day on the ship, and also how cold has it been?
A typical day on the ship depends on what you're doing, what your schedule is. Ian, right now, Ian and Stephen, both their schedules are from noon to midnight. They work a 12-hour shift, and then they switch with Larry, who comes on at midnight and works till noon. There's personnel on the bridge of the ship that work 4-hour shifts, so they're 4 on, 8 off. So they might work from 12 to 4, then be off for 8 hours, and then work 12 to 4 again. So midnight to 4 a.m. and noon to 4 p.m. It depends on who you are and what your job is on the vessel. Second part.
Okay, and we wanted to find out, are you still there, Jillian? Can you hear me?
Yep, we're still here.
Okay, somebody asked, what are they researching about the ocean? So I think there's some confusion about what you're doing in the ocean.
Okay, I'm going to give it back to Ian because that's how we started, was the premise of what we're researching.
Ian, we're not really oceanographers. We're not studying the ocean water itself. We're trying to study the controls on the flow of the ocean water. So if you like, the sort of cradle or the bathtub in which the water flows on a global scale bathtub, and what protrusions there are that impede the flow, that might have kept it from starting in the first place and affecting global climate. So we are not actually making measurements of the temperature and salinity and other properties that physical oceanographers measure. Rather, we are examining the nature of the basin and its history into which those waters do flow.
Okay. And I have your map up that went with the mission. Somebody also wants to know, where are you exactly at the moment? And I will try to put a dot on the map.
We're literally right close to that dot that's already there, to the right-hand dot that says South Georgia.
Oh, okay. There we go.
And right now we're currently, I went up to the bridge before this call, we're currently 1,200 nautical miles from Punta Arenas for our route back, which is about 2,200 kilometers.
Okay. We got that. So I'm putting dots on the map. Okay. We had a question about drinking water. How do you get your drinking water?
That's an excellent question. The ship has a desalinization, we call it a desalinization plant. They take seawater and turn it into drinking water. So we have as much water as we need.
Okay. And another question is about the animals you've seen. What is the majority of the species you've seen?
Predominantly bird life. We've seen a lot of birds. There are a lot of species like the wandering albatross that spend much of their time at sea. So we've seen lots of birds. We've seen a variety of whale species. And then when putting in the GPS stations, elephant seals, fur seals, and leopard seals. Excellent.
Cool. All right. Hold on, working my way through the questions here. What exactly are you mapping on the seafloor? I think Ian explained that, but we can cover that again.
What?
Well, we are mapping the lines of flow of seafloor spreading. They're called fracture zones, and they are along the line in which the ocean has spread. And we are also seeing in some places the ridges, like the present-day Mid-Atlantic ridge, where the Atlantic Ocean floor is spreading apart. In the Scotia Sea, and where we are, there are some extinct spreading centers that are no longer active, and we have passed over at least one of those. So we're mapping those fractures that show the direction of spreading. We're mapping the old ridge crests which told where spreading occurred, and as Stephen discussed, mapping volcanoes that are no longer active.
Yep. All right, we lost them there. So I think, yep, we lost that connection again. So we'll do, yep, a few more questions from these guys. So this is a slide I just put up about what they're looking at on the ocean. Remember they talked about pulling up volcanic samples, and that one of the rocks that they found on the bottom of the ocean they think is about 80 million years from an ancient volcano. The Flagstaff School, you got some great questions about what's interesting and fascinating on the trip, and what it feels like to be away from home for a long period. Hello, are you back, Jillian?
Yep, we're back. We're back.
So we got it. We got the idea about the volcanoes and looking at the geology of the ocean floor here. A couple of questions from your school. What have you found? Did you find any interesting or fascinating? Can you hear me now, Jillian? Oh, I think they're going to lose signal again. All right, so Jillian? No, we lost it. Sorry about that. We'll try to get to these last bit of questions. They're good ones. But again, if we don't get to your question, make sure you put them on the comment section of the journal so that she can respond to them. They're good questions. I'll also probably take a few of these and send them off to Jillian in an email. And that way she can respond to the questions. So anyway, we've been doing pretty good so far with the satellite connections, but not staying on for very long. All right. Well, okay, Jillian.
Hey, Janet.
Yes.
Hello.
Yes. Hello. I'm here.
I just want to let you know we're kind of running out of satellite signal. We would love to hear these questions, and if people could put them in the blog, we'll then be able to answer them.
Yes, I was just explaining that you're probably having some trouble. Why don't you, one of your groups had to leave, so they said thanks, Jillian. But I think the last question here I want to ask you is, what have you found that's the most interesting or fascinating thing on your trip so far?
I'm sorry, Janet, I missed most of that question. I heard the so far.
What is the most fascinating thing on your trip?
If I heard you correctly, I think you asked what was the most outstanding thing we've seen so far, and for me, it's actually been looking at the acoustic equipment and technology that we have to be able to see really
Oh, we lost her. All right, so we're going to wrap this up, and again, I'm sorry about the technical technical difficulties. We just lost them, and it's just the way that they're the ship is going and its connection to the satellite. So we're glad that you were all able to join, and I'm sorry that the Flagstaff students didn't get to talk to Jillian directly, but we will relay your questions to her through email, and be sure to also just send them and post them on the blog, on the journals at PolarTREC. We will archive this and put this out on the website in the next couple of days, so if you need a recap. And if you have time, you're welcome to stay on here for probably one more last connection. And we'll see if Jillian and the team come back, but it's looking kind of bleak. Otherwise, thank you very much for joining. And we just want to also say thanks to National Science Foundation for funding PolarTREC and for ARCIS supporting the program as well. Those are the people that administer the program and where we get our funding. So yeah, we'll try to, I'll stay on for a little bit to see if they come back. And otherwise, I'll let you, those of you that need to sign off, and have a great day.